All right. Hope you all are doing well today. Today we are going to be looking at a code snippet that defines a function that takes in as an argument a list of integers and returns a dictionary of integers as the keys and integers as the values. And we go ahead and submit a list to it and then print out the output. As we move through, you'll kind of get a better sense of what this function is actually doing. Start with, I always like to remind everyone the purpose of memory diagrams is to teach you to read like a computer. Computers do one task at a time. They do it very quickly, but they start at the top and they work their way down. They also read left to right, and then they also read inside. When I say inside out, I mean, for instance, line 11 here. Before we can print, we first have to get back a return value from this functional expression. Cool. Well, let's get started. First things first, we look at line 1. Line 1 has this def keyword that lets us know that we are looking at a function. In fact, everything indented underneath it is part of that function's signature. So, because we haven't yet encountered a function call to count, we store our function over in the heap so that we know where to find it if we need to look at it later. Well, let's go ahead and do that. Create count globals over in the heap. I'm going to say it's a function from lines, let's see, 1 through the last indented line, which is line 8. So lines 1 through 8. I'm going to give it an ID, first available ID, 0. And then we're going to tie it over in globals. Cool. So we have stored that, so we are ready to skip down to the next line. Line 9 is empty, so we skip down to line 10. Line 10 is variable. So we're going to come over here and we're going to say numbers, variable. It's in globals. It's indented furthest to the left. And it is a list of integers that is initialized with the values 1, 1, 0. So, as we learned in class, when we create a list, we stick it over in the stack. I did this the other day, and it's a lot easier to look at. We're going to give it an next available ID, so ID 1. This is a list of integers. And we have 3 values. Index 0 is going to be 1, index 1 is going to be 1, and index 2 is going to be 0. 0, 1, 2. And the values stored in them are 1, 1, and 0. Cool. Almost done. But we have to tie this ID back to the stack. Over in globals, we're going to say ID 1. That's how we find the list numbers in the heap. Cool. Done with line 10. Line 11 asks us to print something. Well, what do we print? Well, we will print whatever we get back when we call count with the argument numbers. So I hit a function call. So I create a function frame. Whenever you create a function frame, you start out with several things. First, you label it the name of the function. Put in a return address slot, a return value slot. What's our return address? It is the line that the function was called on, so line 11. Don't have a return value yet. What else do we need? Well, we look up here in our function signature. And this has a parameter named xs. We'll go over here. We'll create xs. We have our frame labeled. We have a return address. We have a return value slot ready to fill. We have a parameter slot ready to fill. Before we start our function, we have to fill in our parameter slot with the argument. The argument was slotted into this function call in globals. We know we're in globals because we're indented furthest to the left. So numbers, the value stored in numbers, is ID1. So ID1 is actually the argument, the value passed in for XS. We'll put ID1 here. Oh, and now we are ready to step in. Just as a side note, just to clear up, this ID1 here that we passed in, we passed it in because this is how we're going to be able to access this list within this frame. Think of the ID as just like a memory address, an address to this location of this list in memory. So whenever I see numbers, what I'm really saying is, hey, go here, do something with this. But now we're in count. Passed in ID1 as the argument for XS. So now when I see XS, when I'm working inside of this function, I'm also talking about this list here. I'm also saying, hey, go to ID1 and do something with this list. Cool. Alrighty, so we have built out our frame and we are ready to step in. First thing we do, line 2, first line of this function is we create another variable. Variable's name is going to be counts. It's explicitly typed as a dictionary where the keys are integers and the associated values are also integers. Cool. And it also uses the literal form of creating this dictionary, and it doesn't put anything in it, so we're just making an empty dictionary. So in our frame, we're going to create this variable slot, so counts. Yep, counts, sorry. And then over in the heap, we're going to create our dictionary. Okay, cool. And you're going to give it an ID. Next available ID is ID2. This is a dictionary of integers and integers. Actually, we're going to leave this empty because we initialized it as empty. Why is this? Let's just do this manually. Oh, that's good. Right. So we've created our function, or excuse me, our dictionary over here in the heap, and now we just need to tie it back to the stack so that we can use it later. AD2 here, but now whenever we talk about counts, we're referring to this dictionary. Well, let's move on. Done with line 2. Line 3 is a for loop. Basic structure of a for loop is for blank in blank, where the second blank is the data structure we're looping through, and the first blank is what we're going to use to refer to whatever element we're looping through. So in this case, or the element of whatever the structure we're looping through. In this case, we're looping through XS. XS is a list of integers. Well, when we use a for loop to loop through lists, we're looking at this column here, in particular, each individual element in this column, which are integers. Cool. Finally, with a for loop, we create this temporary variable here and initialize it as the first element in the data structure that we're looping through. So the first element in XS is 1. So the first value is going to be 1. As a side note, X is something that we chose as a name. You could name it anything. You could name it element. You could name it number. You could name it rhinoceros. Whatever you want, just as long as you know that it refers to the first element on the first loop through, second element on the second loop through, third element on the third loop through, and so on. Cool. So we set up our everything we need to start off this for loop, and we are ready to step into it. Line 4 says, if x in counts. So we're checking the condition if x, which is 1, is in counts. This if in essentially looks through every single key in a dictionary and sees if any of those keys match X. If they do, this whole statement evaluates to true, and we're ready to step in. Otherwise, if it's not in there, then this statement evaluates to false, and we move to the else statement. Let's check. Is X in counts? Well, counts takes us to this dictionary, which happens to be empty. So is X in here? No way. So, move on to our else block. Our else block says, cool. Go to counts at X and add 1 to the value. So this is how we create a key value pair. Well, so how do we do this? We're going to go to counts. Counts takes us to here, this dictionary, and then we're saying go to X key. Well, there is no X key, so we know we need to create one. And assign the value associated to it be 1. Okay, so come down here. We're going to create a new key value pair. First key value pair is going to be 1 because it is 1. This is 1. Cool. And then we're assigning to it the value 1. 1 goes over here. Do that one more time real quick, just to reiterate. This is how we create a key value pair. This is also how we assign a value to a key value pair, or assign a value to a key. So if X was in here, great, we just reassigned 1 to it. If X is not in there, we create the key value pair and assign 1 to be the value of the key, which is X. Cool. Alrighty, let's move right on. We have hit the last line of our indented block, so we still have more values in this list of XS we're looping through. So we come back up and we reevaluate. Now, because we have already looked at the first value, we now are going to look at the second value. The second value is also 1, so we're reassigning value of X from 1 to 1 again. And you're like, do I really have to do that? When we grade, we're looking for the first and last, but this is a good habit. This is what's actually happening. Cool. So we've reassigned. Now we're checking again. Is X, which is still 1, in counts? Okay, well, we're looking at counts. That takes us to this dictionary. If ins, look for elements on the left of dictionaries. The left column of the dictionary, so looking through the keys. And we're looking for the presence of X, which is 1, in the keys column. Well, is X in the keys column? All right, poorly. Damn right it is. It's the first one. So because X is in counts, being 1, then this whole thing evaluates to true, so we're good to step in. Now, this looks often familiar, right? But instead of creating a key value pair, we're instead saying, hey, go to counts at X, counts, access this dictionary, and we're going to look at X, saying, okay, take the value associated with that, plus 1 to it. So we're taking the value associated with 1, and we're taking it and adding 1 to itself. This becomes well, because the if block was true, we can skip the else block, hit our end of our indented block underneath this for loop. We will loop back up and reassign X to be the next item in the list. So what's the next item in the list? 0. So X comes. Oh, finally, we look through. We check to see if X is in counts. Well, X is 0. Counts is this dictionary. When we do an if in loop, we're looking through the keys column. Is 0 in the keys column? No way. So this evaluates to false. So we skip down to the else block. And we create the key value pair. So counts again takes us to this dictionary. Go to the X key, which is 0 if it exists. It does not exist, so we know we're creating a new key value pair. And we're creating a new key value pair where the key is going to be X, which is 0, and the value, which is going to be 1. Cool. Now what? We've hit the end. Do we have any more elements in this excess list that we're looping through? No. We hit all of the elements in our excess list, so we are done this for loop. And as a result, we move on to the next line. Next line happens to be the last line. Now, what's this line doing? This line says, take the value stored in counts and return it to wherever this whole function call started off. So, this whole function call got started off on line 11. We're taking the value stored in counts, which is ID 2. That's going to be our return value that we returned at line 11. ID 2 goes in return value slot. And as soon as you have a return value slot, or return value in your return value slot, you immediately take this back to where it was called on line 11. So, and this return value essentially replaces the function call. So ID comes back to line 11. This whole thing gets replaced with essentially ID 2. What's really going on? This whole thing gets replaced with a pointer to this dictionary's location in memory. And what are we doing with that pointer? Well, we're asking the computer print. In particular, not necessarily the pointer, we're asking it to print what we get back when we go find that pointer in the heap. Well, we have a dictionary at that pointer in the heap, at that ID. So we are essentially asking ourselves to print this dictionary. Over in output, we are printing this dictionary. Now, Dictionaries get printed out into output exactly the same way that they would look if you'd created them in your code. So we start with curly braces, and then we have keys separated from values with a colon. So our first key value pair is 1, 2. We have 1, 2. And key value pairs are separated by commas. And our next key value pair is 0 and 1. 0, 1, and that's the end of our dictionary. Oh, and that is basically it. As you can see, what this function essentially did was take a list and then create a dictionary with unique numbers that were in that list on the left, and then the frequency of those numbers on the right. There's a couple subtle distinctions, distinctions to be made. One is we first checked to see if x was in counts. Why do we do that? Well, because if we didn't, then every single time we found a new element, we would just be reassigning to be 1 instead of upping it by 1. It also ensures that our keys in our dictionary are unique, which has to be the case. One of the special rules of dictionaries is that this column has to have all unique numbers, no repeats. It's fine, those can be repeated. The left has to be all unique numbers. Cool. And that is it for this memory diagram. I hope this was helpful. If you're at all confused, please consider coming to office hours or tutoring. I have tons of TAs there that are ready to help you dissect this. So, and with that, I hope you all have a great day. Take it easy.